Hello dear students, welcome to Quantum Light. So today's session we are going to solving the numericals based on the chapter force. So in that exercise 1a, so numerical 1. A nut is opened by a wrench of length 25 centimeter. If the least force is required is 10 Newton, find the moment of force needed to turn the nut. That means they given two physical quantity. So length is 25 centimeter and the force is 10 Newton. So they ask us to calculate moment of force. So let us write the given data neatly. So given. So what they given? Given length of a wrench. That means the perpendicular distance is equals to 25 centimeter. So which is in CGS unit, we should convert it into SI unit. So 0.25 meter. And the force F is given is equals to 10 Newton. So they ask us to calculate the moment of force. So tau is equals to question mark. Now we know that tau is equals to force into perpendicular distance. Now substitute these two values in this relation. So force is 10 Newton into perpendicular distance is 0.25 meter. Now multiply these two things, we get moment of force. So the moment of force is, so 10 into 0.5 is 2.5 Newton meter. So SI unit of moment of force is Newton meter. So hence the required moment of force to turn the nut is equals to 2.5 Newton meter. Next, the second numerical. A wheel of diameter 2 meter is shown in figure with axle at O. A force F equals to 2 Newton is applied at B in the direction shown in the figure. So calculate the moment of force about, the first one is the center O and the second one is the point at A. So here is a given diagram. Okay, so first the force is acting at B, then the diameter given, so total diameter. Okay, so let us write the given data first. Given, so diameter of a wheel is equals to 2 meter. So what about the radius? Of the diameter is equals to radius, no, so 2 by 2, that is equals to 1 meter. That means from point O to B is nothing but 1 meter, from point A to B is nothing but 2 meter. Now they ask us to calculate the moment of force about the center O. So about the center O, so the perpendicular distance is equals to radius. Okay, so we know that tau is equals to force into perpendicular distance again. So in that first one, the moment of force about O. Okay, so tau is equals to force is nothing but how much given force? So force F is equals to 2 Newton. So force is equals to 2 Newton into perpendicular distance from O to B is nothing but 1 meter. That means radius equals to 1 meter. So tau is equals to 2 Newton meter. That means the moment of force about O is equals to 2 Newton meter. Then second one is the moment of force about point A. So about point A, that means this thing. So moment of force about A, from A to B. So radius is again here 1 meter plus 1 meter. So total diameter equals to D is equals to 2 meter. So the perpendicular distance equals to 2 meter, force is 2 Newton. Again, we're using same formula, tau equals to force into perpendicular distance. So tau is equals to, yes, force is again the same, 2 Newton, and the perpendicular distance from point A to B is 2 meter. So that is equals to the 4 Newton meter. That means the moment of force about A is equals to 4 Newton. Next, numerical 3. A 50 kg mass is being lifted by using a 1 meter long lever. If the length of the lever is reduced by 20%, how much more or less force is to be applied to achieve the same torque? Okay, so write the given. So what they given here? So here they given mass. Mass is equals to 50 kg. Okay, so let us calculate the force first. So F is equals to M into G. So M is given 50 into, then acceleration due to gravity 9.8, that is equals to 490 Newton. Now, so let us calculate the torque. So torque is equals to force into perpendicular distance, but here the perpendicular distance is 1 meter, so 1 meter. Now substitute the value here. Force is 490 into 1 meter, so that is equals to 490 Newton meter. So this is a case 1. Take case 2. If that length of a lever is reduced by 20%, okay, so here the perpendicular distance is 1 meter. So if the length is reduced by 20%, so perpendicular distance is equals to, so R minus 20% of its original length. So that is equals to perpendicular distance minus 20%. We can write 20 by 100 into perpendicular distance. So that is equals to perpendicular distance minus 0.2 into perpendicular, that is equals to 0.8 perpendicular distance. So R perpendicular is equals to, so 0.8 into perpendicular distance is 1 meter, so 1, that is equals to 0.8 meter. Now, so find the torque. So again, torque is equals to force into perpendicular distance. So let us take here torque 1 and here torque 2. So torque 1 is equals to torque 2. Okay, now torque 2 is equals to force into perpendicular distance. So torque 2 is equals to torque 1. So torque 1 is equals to 490 Newton meter. 490 Newton meter is equals to, so force we don't know, we need to calculate, into perpendicular distance we found 0.8 meter. So force is equals to 490 divided by 0.8 meter. So force is equals to 612.5 Newton. So here torque 2 minus torque 1, that is equals to 612.5 minus 490, so that is equals to 122.5 Newton. That means, therefore, force required to produce the same torque will increase by 122.5 Newton. Next, numerical 4. When mechanic applies a force of 100 Newton at the end of the spanner to tighten a bolt, the length of the spanner is 0.5 meters. So how much the torque is exerted on the bolt? If the mechanic increases the force by 20% but holds the spanner closer at 0.4 meters, so would it result in an increase or decrease of torque? Okay, so again write the given. So here we have two cases. We take case one, first case. Okay, so force is equals to 100 Newton and the perpendicular distance is equals to 0.5 meter. So let us calculate the torque 1. Torque 1 is equals to, so force into perpendicular distance. So that is equals to 100 into, so 0.5, so that is equals to 50 Newton meter. So in case 2, if the force is increased by 20%, so new force F is equals to increase by 20%, so F plus 20% of its original force, that is equals to F into, so 20 by 100 into F, so that is equals to F plus 0.2 F, so finally we get 1.2 F, so that is equals to 1.2 into F value is 100, so that is equals to 120 Newton. So F, but that mechanic holds the spanner closer at 0.4 meter, so perpendicular distance R2 is equals to 0.4 meter. So next, torque 2 is equals to force into perpendicular distance, that is equals to 4 is 120 into perpendicular distance is 0.4, so that is equals to 48 Newton meter. Now, so torque 1 is minus torque 2 is equals to, so 50 minus 48 is equals to 2 Newton meter. That means, therefore, the torque required, the torque will, sorry, not required, torque will decrease by 2 Newton meter. So whenever we are increasing the 20% of the force applied and we are decreasing the perpendicular distance from 0.5 to 0.4, the torque will decrease by 2 Newton meter. Next, numerical 5. A steering wheel of diameter 0.5 is rotated anti-clockwise by applying two forces, each of magnitude 6 Newton. So draw a diagram to show the application of forces and calculate the moment of force applied. Okay, so draw the diagram. They given some diameter and magnitude of force. So two forces, each of magnitude 6 Newton, and they ask us to draw the diagram also. So steering wheel, okay, that has center. So that of the diameter is 0.5 meter. So let us take A and B. So but it's rotated anti-clockwise by applying two forces. Okay, so one is in this direction, so F is equals to F1 equals to 6 Newton, the another one is the opposite direction. So F2 is equals to 6 Newton. Now they asked us to calculate the moment of force, but here two forces acting, that means moment of couple. So write the given data. Diameter D is equals to 0.5 meter. Then force F1 is equals to 6 Newton. F2 is equals to 6 Newton. So they asked us to calculate moment of couple is equals to, we know the formula. So either of force into couple arm. Okay, either of force. So take F1 or F2. So 6 into couple arm from A to B is nothing but a couple arm. So that is equals to 0.5. So that is equals to 3 Newton meter. So moment of force is 3 Newton meter.